All right, so these notes are going to be over our laws of exponents. If you look in the top right-hand corner, there's a diagram of an exponent. The x value is that large base number. It is called the base. It is what we are multiplying. And the n value, that is smaller and written to the right of the base, is called the exponent. So go ahead and write that diagram. All right, the base. The base is the factor that is repeatedly multiplied. So if we were to work this out, the factor would be x. And n would tell us how many times to multiply x times itself. So x times x times x, and so on. N is our exponent. The exponent is a value that shows how many times to multiply a base by itself. So underneath that title, Laws of Exponents, the blank must be the same in order to apply these laws. It's the base. The base must always be the same in order for any of these laws to work. Okay, if we have two different bases, then we cannot use these values to simplify. All right, so product of powers, this is our rule. They're illustrating this with letters. The reason that they're using letters is to show you that it doesn't really matter what the number is, the rule stays the same. Okay, so if you see that both of these have the same base, but two different exponents. And what are they doing with the exponents to simplify? They're adding them. So product means that we're multiplying. When we multiply, we are going to add the exponents. Okay, we're going to do a few examples on this right-hand rectangle. For example, if I give you 5 to the third times 5 to the fourth, we would keep the base the same, and we would just add those exponents. So to show the work, I'm showing you 3 plus 4. And simplified, that is 5 to the 7th power. Okay, why does that work? Well, 5 to the third is 5 times itself 3 times. And you're multiplying it by 5 to the fourth, which is 5 times itself 4 times. And if you're multiplying everything, then how many 5s total are you multiplying? Actually 7. So that's why that rule works. You have a group of 3 and a group of 4. You're multiplying all of them together. They're all the same. So just say that it is 5 to the 7th. Okay, power of a power. Okay, that's where we have an exponent raised to another exponent. So we have our base raised to m, and then everything is raised to n. And what they're showing us here is what operation? Multiplication. So in this case, when you have a power of a power, you multiply the exponents. Okay. And so what does that look like as an example? Let's write in parentheses 3 to the fourth raised to the second. Okay, and if we follow that rule, then we're just going to we're going to keep the base, and it's going to be 4 times 2 as the exponent. And 4 times 2 is, very good, 8. So simplified, this would be 3 to the 8th. So we can just go from 3 to the 4th raised to the second directly to 3 to the 8th if we just do 4 times 2 here. Now, 3 to the 8th is an actual value. We can evaluate it, but right now we're just going to focus on using the rules. Okay, negative exponents. Negative exponents is normally when we see a negative value and there's multiplication involved, we think of that rule, a negative times a negative is a positive, and a negative times a positive is a negative. Okay, well this number is not being multiplied. It's telling us how many times to multiply the base. And in order to force this to be positive, because we like to think in positive terms, you would take this value and understand that any whole number can be written as a fraction by putting it over 1. We can rewrite it so it's positive by moving it to the denominator and rewriting it as 1 over that value. So if it's in the numerator and it's negative, move it to the denominator. And it works in the reverse form also. If it's negative in the denominator, we can move it to the numerator and it'd be positive. Okay, so I'm going to give you a small example. 7 to the negative third. What would my numerator become? Look at our example. So that should be equal to 1 over, and I'm just going to take this entire thing and rewrite it as a positive. 1 over 7 to the third. Okay, we're going to do an additional example to the right side of that. So if I write x to the negative fourth, what would my rewrite look like? Perfect, 1 over x to the fourth. Okay, so let's look at our next set of rules. Quotient of powers. What does quotient mean? What operation? Yeah, it means that we've done some sort of division, right? Okay, so when we multiply, we add the exponents. When we divide, what do we think we're going to do? Subtract the exponents. Okay, notice that in the diagram here, m is the numerator in the numerator exponent, and n is the denominator exponent. And the order does matter. We do top minus bottom, but the base does have to be the same. So we did a, m minus n. Okay, so our example, let's do 8 to the 5th over 8 to the 3rd. Okay, and if I follow that rule, I'm supposed to subtract numerator minus denominator, talking about the exponent. So that's going to be 8, and it's going to be 5 minus 3. And what is 5 minus 3? So I'm going to get 8 to the 2nd. And why that works, if you set this up, if you expand these to their factors, this is 8 times itself 5 times on the numerator, and 8 times itself 3 times on the denominator. And if you remember, whenever you learned to simplify fractions, you factored them, and then you found that if the numerator and denominator had the same factor, you could cancel them out, because a number divided by itself is always equal to 1. And 1 as a factor doesn't change anything, does it? Anything times 1 is whatever you started with. So these cancel, and what am I left with? 2 8s. 8 times 8 is 8 squared. That's why that rule works. Okay? 0 exponents. Any value to an exponent of 0 is going to be equal to 1. So if I give you 9 to the 0 power, what is that equal to? 1. If I give you if I give you z to the 0 power, that is equal to 1. I doesn't matter what that value is as the base. If it's raised to an exponent of 0, it is equal to 1. Okay? Our final rule is power of a quotient. Okay? So that means that we have a fraction raised to an exponent. What does it look like they're showing us here? That the exponent goes for both the numerator and the denominator. So we can share it with both the top and the bottom of that fraction. So for example, 7 over 10 raised to the 5th, share it with the numerator and share it with the denominator. And we could simplify from there.